Welcome back to Tail Air, and today we're going to be looking at how to fly this Nat7 SID without programming it into the GPS and flying it on raw data on the needles using the new G1000 Nxi. See, the note here says ADF and DME required. That's because this procedure requires an NDB backtrack and a DME Arc. If you didn't know, SID stands for Standard Instrument Departure, and the Nat7 is the departure that serves the Rogue Valley International Airport in Medford, Oregon. Some people also call it a DP. DP stands for insert your own joke here, or maybe insert two of them at the same time. We're currently on runway 14 at the Rogue Valley Airport. So let's set up our NAVAIDs. The first one we're going to set up is the NDB. So you'll see here we've got the Medford NDB as part of the procedure. We therefore need to make sure that that's tuned. The frequency for the NDB is 356. So we're going to make sure that we've got that tuned in the ADF area here. We also need to tune the Rogue Valley VOR, which is a frequency of 113.6, which idents as OED, which we'll be needing later. Also going to set up the CDI on the PFD, which is the course deviation indicator. I'm going to do that by clicking on the CDI button behind the yoke here. I'm going to set the course to 333. I'll explain why later. I also need to set up my bearing indicator needles. Now for bearing 1, which is on the button behind the yoke here, I'm going to set up the ADF. That will allow me to track the NDB using the single line needle, as you can see here. I will be using bearing 2, but I'm going to set it up later to avoid too much clutter on the PFD. Okay, so I've tuned and identified all of my NAVAIDs. So what I'm going to do now is I'm going to take off and we'll talk through the procedure as we fly it. So we're currently rolling down runway 14, and you'll see here on the plan view that after takeoff we need to make a right turn to the heading of 350. And you'll also see that here on the text explanation of the departure as well. Now you'll notice that there's no specified height that we need to make that turn. So what we're going to do is we're going to climb straight ahead initially to 400 feet and then we'll start the right turn after that. The elevation at this airport is 1335 feet, which means that we need to be at least 1735 feet before we make that right turn. And then once we've established onto the 350 heading, what we need to do is just wait until we're on the 272 bearing from the NDB and then make a left turn to track that outbound towards Nats. What we'll be using to determine our bearing from the NDB will be the blue single line bearing indicator on the PFD, and because we're tracking away from the NDB, we're going to be using the tail of the needle in order to track away from the station. So we're above that 1735 feet now, so we can start the right turn in order to go around to the heading of 350. I'm going to do that at a standard rate. Now on the G1000 you can tell if you're doing a standard rate turn by looking at this magenta line coming out of the top of the direction indicator here, and when it's lined up with this white line here, you're completing a standard rate turn. And at this kind of speed I'd expect a standard rate turn to be around about 15 degrees angle of bank, so it's looking about sensible. You'll see as we come around the corner here that the head of the blue needle is pointing towards just the right side of north, so maybe about 005. That's showing us that the NDB is going to be slightly off to the right of us when we roll out onto the 350 heading, which is fine because we don't need to go over the NDB because it's an intercept of the course away from the station. So we've just rolled out onto the heading of 350. Now what we need to do is keep that climb going, and we're going to keep an eye on the NDB needle. We're looking for the tail of the needle to start moving its way around towards 272, which is the outbound track from the NDB. Now, we're very close to the NDB, so we need to make sure that we don't overcorrect or fly straight through it and not realize that the needle's moving. So I'm just going to set my heading bug to 272 on anticipation of that needle starting to move. The winds in the sim are pretty light today, so not expecting too much wind correction required for this one. Okay, you can see here the tail of the needle is now starting to come round towards 272. So what we're going to do is we're going to start that left turn towards the heading of 272 and try to catch the needle as it hits 272. Now remember, we are very close to the NDB here, so the needle will move very quickly. So as I've rolled out there onto about 272, I can see that the tail of the needle is still about 20 degrees to the left of me. Now remember, this is reverse sensing because we're tracking the tail, so what we need to do now is we need to turn right to pull the tail round towards 272. So I'm going to go maybe 10 degrees to the right to about a heading of 280, and that should pull the tail to the 272 bearing that I'm looking for. Now we're still very close to the NDB, so really not big corrections required, so 10 degrees is perfectly fine at this distance from the NDB for this. I'm just re-identifying the NDB. Last time I made an NDB video, somebody did make a very valid comment that you're supposed to monitor the Morse code on the NDB all the time. However, because that would make an extremely horrible video listening to the Morse code the whole time, I'm not going to do it, but I will re-identify it on this occasion here. And you can see there that the tail of the needle is coming around quite nicely towards the heading bug there. So we'll set that turn now back towards the 272 heading, and that should just about match up with the track, so that should maintain the outbound track for the NDB. Okay, so we're now established on the track to NATS. Now what we have to do is work out how we're going to identify it. So you'll see earlier that I made a pop-up note saying that I was activating bearing 2. If you have a look on the PFD there, on the direction indicator, you'll see an overlay of another bearing indicator with 2 lines instead of 1. It's still blue, but it's got like 2 parallel lines on it. What that is bearing number 2 pointing towards the VOR. Now, in order to identify NATS, we need to have a look at the radial coming from the VOR and cross-cut that with the bearing from the NDB. So you can see here that the radial 216 from the VOR, while we're on the bearing of 272 from the NDB, when that crosses over, we are at the NATS intersection. So that's what we're going to be looking for on the PFD. And you can see here on the chart as well that when we get to the NATS intersection, we should be seeing around 6 DME from the VOR, which will act as a sensible cross-check. So in practice, what we're looking for here is the tail of this needle to come around to 216, and the DME over here to read 6 DME or thereabouts, and then we know that we're at the correct place. So what happens after NATS? Well, have a look at the chart here and you'll see there's a number of ways that we could go. These are called transitions. They'll be assigned to you by air traffic control, and today we're going to do the Mour transition, which is roughly following the magenta arrows that I've lined out on the chart. The FAA also gives a text version of the departure and the transition, which can be seen here. So we're currently on this part, takeoff from runway 14, where it says we make a climbing right turn to a heading of 350, which we've already done, to intercept the bearing of 272 from the MEF NDB, which we've already done, to the GATS intersection, and then quite possibly my favourite out-of-place medieval word ever, thence ... Thence we shall go forth on our quest for the Mour intersection, via the sacred path of the DME Arc, and only the worthy shall... I'm going to stop this now. So it says here, from over the NATS intersection, we continue on the 272 bearing from the NDB to the Mour intersection. So basically we just continue in a straight line after we pass the NATS intersection there. So let's see how things are going back in the cockpit. So you'll notice here that I've actually reduced the climb speed towards the VX speed. That's because if you have a look on the chart, there's a 6,600 or above altitude restriction for the next part of the departure. And I was thinking we weren't going to make it, so what I've done is I've reduced the speed towards the VX speed, which is the best angle of climb, so that'll give me less ground coverage as we gain altitude, so that means I should be able to make that restriction. Alright, so where are we? So if you have a look at the NDB needle here, you'll see the tail of the needle still pointing to 272, so we are still on track towards NATS, and you see the tail of the needle that we're using to get a bearing from the VOR is showing about 210. Which means that we're coming up to NATS. We've got about 6 degrees to go there before we are showing the correct radial for NATS intersection. The DME is just over 5 as well, so that's looking pretty good too. So that puts us around about here. And while I've been talking there, you see the bearing 2 needles come round to 216, and the DME showing about 5.7, which is close enough to 6 for me. So we are now over the NATS intersection. And you see the altitude there is over 6,600 feet as well, so we've also made that altitude restriction. So now we just need to continue tracking this all the way up to Mour. We'll know we're at Mour when we are showing a 251 radial on the bearing number 2 indicator and 15 DME from the VOR. After that point we need to make a right turn onto the DME Arc. And you'll see here that the minimum altitude for the DME Arc is 7,500, and that is the most restrictive altitude for this procedure. So I'm going to level off at 7,500 feet when we get there. Now we already are at 7,500 feet because I actually made the playback go faster so that we could get a bit closer to the DME arc. So we're now around here on the chart. So the tail of the needle here is about 250, and you see the DME is around 13.5. So we're about a mile and a half from the 15 DME that we need to be, and about 1 degree off of the radial. So that's looking pretty good. So I'm going to set the heading bug around to about 90 degrees to the right, and then what I'll be using is the head of the bearing number 2 needle, and I'll be putting that about 90 degrees on the right side of the HSI there, so on the right wing basically. And you'll see the DME now is around 14.3 from the OED VOR. We will use up a bit of mileage in the turn, so what I'm going to do is start the turn now to anticipate hitting that 15 nautical miles as we roll out onto the arc. So like I said, we're going to put the head of the needle about 90 degrees to the right. So what I'm going to do is I'm going to put the head of the needle against this marker here, then I can level the wings, have a look at the DME, and then see what the situation's like. Also, during the turn, I can alter the rate of turn in order to try and achieve that 15 DME on the rollout. We'll see how I do. So not too bad, 14.8 nautical miles. So what I've done is I've just rolled the wings level a little bit early. So you'll see there that the head of the needle is actually showing a little bit more than 90 degrees. And what that will do is it will widen us out slightly to hit that 15 nautical miles so that we're established nicely on the arc. Okay, so there's the 15 nautical miles. So what we can do now is make that right turn and put the head of the needle on the 90 degrees to the right marker, and then basically just look at keeping it there all the way around the arc, and then that should maintain the 15 degrees. The wind's very light in the simulator, so we don't have to make that much wind correction, but we will make a video in the future to show you how to correct for wind. So what we're seeing here is the bearing needle is always pointing towards the VOR. So if we keep it at 90 degrees to the right the whole time and the wind's pretty much zero, what's going to happen is we're going to do a perfect circle around the VOR, and therefore we'll keep a constant radius of that circle, which is the whole idea of the DME arc. So you'll see here that the DME has gone to 15.1 nautical miles. What that means is that we've slipped slightly outside of the arc. So what we need to do is turn a little bit sharper inside so that we can close in that DME distance to 15 again. So that will mean putting the head of the needle slightly inside of the 90 degrees instead of outside. So now all we have to do is keep turning to keep that head of the needle on the inside of the 90 degrees, and then the DME will eventually go back to 15 degrees, and then we can just continue putting it back on that 90 degree point as before. And there we go. So in case you were wondering why the altitude restrictions are so high on this departure, if we have a look on the PFD here, you'll see that there's quite a lot of mountainous areas around. But if we have a look out the window, you can actually see the mountain ranges, quite high peaks around this area. So that's why the altitudes are so restrictive here. And they look nice now, but I bet they don't look so nice if you pop out of a cloud and you get one staring you right in the face. So I've accelerated us around the arc, and you'll see that we have to come off of the arc at this Uzehi intersection, and then make a left turn inbound to Mour. And you'll see there that that's a 333 radial from the VOR. So that is why I set up this green CDI needle. So I've set that up for 333 course from the VOR. So what we're going to be looking for now is for the CDI needle to come in towards the middle, and that will mean that we've intercepted the 333 radial, and therefore we can make the left turn and then head to Mour. And you'll see it's already showing about half scale deflection. So what I've done is I've started the left turn already to make the turn towards the 333 radial, and then we'll just close that in slowly as we get there. So I've leveled the wings here on about north, which gives me about a 30 degree intercept to get onto the radial, which is a sensible intercept considering the distance we are from the VOR. And now we just need to wait for the CDI needle to go into the middle. So you see it's coming a little bit further now, so I'm just going to take another 10 degrees off the intercept and go for about 350 on the heading. That just makes it a bit more comfortable to actually intercept it when it goes into the middle. And there we go, needle's now more or less centralized, so all we need to do now is just take up a heading to maintain that. Okay, so now we're established on track to Mour from Uzehi. We need to travel 16 miles from Uzehi, and then we will be over the Mour intersection, which is the termination of the transition, so it's nearly over. But how do we identify that? Well, you'll see here on the chart it says in the D here with the arrow on it, 31. And that means that the Mour intersection is 31 DME from the VOR that it's referring to, which is the OED VOR that we've been using all along. So as soon as the DME reads 31, that means we're over the Mour intersection as long as we're still on the 333 radial. Okay, so I accelerated us ahead because you didn't really want to watch me fly straight and level for 16 miles. If you have a look at the DME here, you can see we are just over 30 now on the miles from the VOR, and we're still on the 333 radial, which means that we are almost at Mour, and it puts us about here on the chart. So all we need to do now is wait until that hits 31, and then we know we are over the Mour intersection and we've completed the standard instrument departure. And there's Mour, and speaking of which, I'm off to mourn the time I wasted editing this video when nobody is going to watch it. Thanks for watching.